Hello everybody, Sorlian here, and today we are looking at depreciation and appreciation. And at the end of this video, you should be able to calculate those two very things, the depreciation of an item and the appreciation of an item. So first, let's head into depreciation. So when we talk about depreciation, we're talking about the reduction in value of an asset over time. Now, this is often due to wear and tear of the item, the age of the item, or sometimes the item may not be in style. Like for example, an iPhone 5 probably cost about $60,000 about 10 years ago. But now, nobody's paying $60,000 for an iPhone 5 because it's outdated. So that is the cause for, that is the reason for depreciation. Now, so if you buy a car and it cannot be worth the same value that you bought it. Let's say you bought a car in 2016, it cannot be worth the same thing in 2024 because you would have driven and damages would have happened and wear and tear. So that is the reason for depreciation. So today we'll be looking at how we can calculate the depreciation of different items. Now, there's a formula that we use to find depreciation given the number of years, and that formula is the value after n years. N is just there to represent an amount of years. The formula is the initial value of the item multiplied by 1, subtract the depreciation rate, now this is given, divided by 100, all raised to the n power. And n is the amount of years that the item has depreciated for. So sometimes you may not even need a formula to find depreciation, and I'll show you that in one of the examples. Nevertheless, let's head into the first example. So the first example is a car is bought for $20,000 and depreciates at a rate of 10% per year. Calculate the value of the car after 3 years. So the thing is, we can actually work this question without the formula. We can first find 10% of the 20,000, and that will be, and we subtract that answer from the 20,000, and that will be the cost for the car after 1 year. And then we find 10% of the new cost, and we subtract that, and that will be the cost after 2 years. And then we find another 10%, and we subtract that, and that will be the price of the item after the 3 years. But that is a long process. Probably if we have 1 year, we want to find how much the item costs after 1 year, we can do that approach. But for this one, we want to use the formula. So the value of the item after n years would be the initial value, I'll just use IV, multiplied by 1, subtract the rate, just use R for rate, over 100, all raised to the n power. So we can put in our values that we know. So the initial value for the item is 20,000. So this will be 20,000 multiplied by 1, subtract the rate, which is 10% per year. This will be 10 over 100 raised to the n year, which is 3 years, because it depreciated for 3 years. So this will now be, so 20,000 multiplied by 1, subtract 0.1. So when we work out this bracket, we will get 0.9. And if we raise 0.9 to the third power, that would give me 0.729. So this will now be 20,000 multiplied by 0.729. And this will work out and give me $14,580. And that would be the value of the car after 3 years of depreciation. So it's just for us to work out the formula. So you want to work out everything that is going on in the bracket for the formula, and then when you finish working out what is going on in the bracket, you raise that to the power, and then you multiply that by the original value, and that would give you the answer. And that's it for depreciation. Now let's look at appreciation. Now, appreciation is kind of like the opposite of depreciation. For appreciation, this is the increase in value of an asset over time. Now, this is usually due to demand or limited availability. And this will often This will often be as it relates to land and minerals and so forth, oil, and it depends on demand. And antiques, these things that, like for example, a car from the 1800s, if you have a car like that, each year that the value of that car will increase because of how rare it is, and that is appreciation. So the formula for appreciation is very similar for depreciation. The only difference is, instead of subtracting, we are adding for appreciation, because of course the value will increase. So let's look at this example. So this example says an art piece was purchased for 5,000 and is expected to appreciate at a rate of 8% per year. Calculate its value after 4 years. So we use the formula. So I'll just use shortened form. So the value after n years would be the initial value, so I'll just use IV, multiplied by 1 plus the rate over 100, all raised to the n power. So we see that the initial value is 5,000. So it's 5,000 multiplied by 1 plus the rate, in this case, which is 8 over 100, all raised to the n power, which is 4 years. So we put in those things first, and then we work out. So this will be 5,000 multiplied by 1 plus, now 8 divided by 100 to give me 0.08. And all of this will be raised to the 4th power. So when we add 1 plus 0.8, we have 5,000 multiplied by 1.08 raised to the 4th power. 1.08 raised to the 4th power. And if we raise 1.08 to the 4th power, 1.08 to the 4th power, that would give us 1.3604, and so on. So we'll take that answer that we will get. So this will be 5,000 multiplied by 1.36048. So let me use 4 decimal places. This will be 1.3605. So when I multiply 5,000 by 1.3605, I will get $6,802.50. And this would be the cost of the item after it appreciates in 4 years. So it's just for you to do the same thing like what you did just now. You work out what is going on in the brackets, and then you raise it to a certain power, and then you multiply that by the initial value, and that would give you the appreciation value after the certain amount of years. So let's look at another example. So this example says a piece of land is bought for 25,000 and appreciates 7% each year. Determine the value after 5 years. So we know the formula. The value after n years is equal to the initial value multiplied by 1, since we're talking about appreciation, plus r over 100, all raised to the n power. So the value will be, the initial cost is 25,000. This is 25,000 multiplied by 1 plus the rate, which is 7 over 100, all raised to the 5th power. So this is equal to 25,000 multiplied by 1 plus, so 7 divided by 100 would be 0.07, all raised to the 5th power. This will be 25,000 multiplied by 1 plus 0.7, raised to the 5th power. So when we work out this bracket, 1.07 raised to the 5th power, that would give me 25,000 multiplied by, when I work out this bracket, I'll get approximately 1.4025. And when I multiply 25,000 by that, I will get a value of $35,063.75. And that would give me the value of the item after 5 years, after it appreciates by 7% for 5 years. So it's just for us to work out using the formula. So let's explore another question. And this question, I will try a different approach and to using the formula. I will reason my way out for this question and see if I can get the answer without the formula. So this question says, a machine worth $25,000 depreciates at a rate of 12% per annum. Calculate the value of the machine after 1 year. So we see that after 1 year, this vehicle will be worth 12% less than what it was initially worth. So to find that, I will just find 12% of the 25,000. So this 0 cancels with that 0, this 0 cancels with that 0, and 12 times 250 give me $3,000. So this is the amount of money that has to come off of the vehicle after the 1 year. So this will be 25,000 subtract $3,000. So 25 subtract 3,000. That would give me a value of 25,000 subtract 3,000 would give me a value of $22,000. And that is what the machine will be worth after it depreciates for 12% after 1 year. So I did not use the formula. And if you go and try and use the formula, you will see that you will get the same answer as I have. So it's just I just reasoned my way out. I saw that it's 12%. So I take off 12% from the 25,000 and I end up with 22,000. And if you use the formula, you will get the same answer. Let's look at the last question. And I will not use the formula for this last question either. So this one says, at the end of each year, a laptop is worth 8% less than it was worth at the beginning of the year. So if the laptop was worth $1,200 in January 2020, what is its value in December 2020? So we see in January to December, that is 1 year. So we want to find the cost of this laptop or the value of this laptop after 1 year of depreciation. So once again, I will find 8% of the cost at January. So this will be 8 over 100 multiplied by the cost of the laptop, which is $1,200. So this 0 cancels with that 0, this 0 cancels with that 0. And 8 times 12 would give me $96. So we see $96 has to come off of the laptop. So this will be $1,200 subtract $96. So 1,200 subtract 96 will give me $1,104. And that would be the value of the laptop after 1 year, or from January to December, because we know that's 1 year. And with that, it has brought us to the end of this video. So in this video, we learned how to calculate depreciation, and we saw that we can use the formula, especially when you're given large amount of years. It's easier to use the formula. But if you have just 1 year, you can just find the percentage of the item, and if it's depreciation, you subtract. If it's appreciation, then you add that to the item if it's just 1 year. But if it's more than 1 year, we have to use the formula, which says the initial value for appreciation. So we have to use a formula. And for appreciation, it will be the initial value multiplied by in bracket 1 plus the rate divided by 100, all raised to the n power, which is the number of years. And for depreciation, we're just subtracting instead of adding the 1. So I trust that you now have a good understanding of depreciation and appreciation, and I'll see you in the next video.